Let's recap the training error curve and test error curve. When you draw a error graph, a machine learning algorithm with respect to the number of parameters or the number of capacity of your algorithm or number of complexity sometimes of your algorithm, and let's say n denotes the number of parameter or number of capacity or number of complexity if you want. Then we have this monotonically decreasing curve for your training error and some U-shaped curve for your test error. Okay, and the U-shaped curve comes from the overfitting phenomena. And we don't want overfitting, so for the machine learning, it is very important to find out the proper n that minimize the test error, where we usually have very small gap between test error and training error. So this is very basic of machine learning. But when you train some algorithm with different number of parameters and when you draw the graph, you might see some weird thing. Your training error might not be monotone. There are some up and down, and even some cases there are some increased behavior when you draw your training error with respect to the number of parameter or number of capacity n. Why this up and down happen? Why this increasing training error happen? Although you use more degree of freedom, more parameters to train your train data point. Right. So there are some reasons. The training error will be monotonically decreasing function with this sufficient condition. With this sufficient condition, you can guarantee your training is monotonically decreasing. The first one is loss function is equal to the error function. The second one is we always solve the training optimization problem. Mean your training parameter with respect to this loss function. And the third condition is your function class with n1 number of parameter is subset of your function class with n2 number of parameters for all n1 smaller than n2. So which means if your training is not monotonically decreasing, at least one over this condition is not satisfied. Okay, let's see the first case. What is the meaning of loss function is not error function? So when you train your algorithm with this yi minus fxi, this absolute mean loss value. But when you plot the training error curve using this L2 loss function, sometimes although your algorithm decrease the training loss with respect to this L1 loss function, the error loss using the L2 loss could increase. So from this mismatch between loss function and error function, you might observe some up and down in your training loss or training error curve. Okay, so this is the first reason, and in practice you might see some up and down in your training error curve. The second one is the error on the optimization problem. So you have to minimize the loss function by controlling your parameter beta. Okay, so ideal machine learning algorithm can always find the beta, then minimize the loss function. But in practice, sometimes it is almost impossible to find out the beta, then minimize the loss function. Especially nowadays using deep learning, it is impossible to find beta hat that really minimize the loss function. So we usually have beta hat which is not minimum value of loss function. So ideally, we have a monotonically decreasing the training error. But because of the error, beta hat not equal to mean of L beta, there is some gap between the ideal training curve and the trained real training error curve. Okay, because of this gap, you will have some up and down in your training error curve. So this is training error curve with respect to the number of parameters or the number of capacity or complexity. Right. The third condition is the case your function class with n1 number of parameter is not subset of the function class with n2 number of parameters with n1 less than n2. In this case, which means when you draw the Venn diagram for the function class fn1 and function class fn2, there is some component which belong to fn1 but not belong to fn2. So if your solution for fn1 class is located here, then fn2 does not have this red point. Maybe, although you have much more degree of freedom, much more flexibility, much more option to choose, the solution of fn2 could be worse than the solution of fn1. So because of that, maybe your training error can up and down, although you increase the number of parameters, right? So in this video, I review 3 possible cases which can cause some up and down in your training error curve when you really implement some algorithm, some class of algorithm, and you really plot the training error with respect to number of parameters.